Okay.
It is not 3 nanometer. But future
Maybe
we can
in conclusion, you mentioned it as 3 nanometer size. So just I want to clarify the size of the memristor you used for the implementation.
But that is not 3 nanometer size, madam.
So what is the size you used for the implementation of AND gate or inverter, CMOS inverter, whatever you displayed here?
Madam, actually, in that spice nest we have seen means they are not mentioned anything about nanometer, madam. We have just created inserted the spike list in the LT spec, then we got the symbol. So to check whether it works as a memory store only, we got this curve, this curve. And still we didn't get into detail about the technology, what they're using now. Just we simulated, okay, it is good. Then later on we need to proceed in the cadence.
You are able to see that inside the netlist or the details, whatever they are given. I think it might be available, sir. You just
okay, madam. Okay, I will cross check, madam.
And if it's a suggestion from my side that if you are having like a comparison with that or some technology, that's the reason I went for which nanometer you used for that. So if you are showing us a comparison there, then it might be good since you are able to proceed with further. As you mentioned, cadence software, when you are going, you can able to calculate the power consumption, delay time and other thing. So if you are keeping us in comparison with the MOSFET as well as the memristor, then it might have a better presentation, I feel.
Yes, but next time that is what's our target, madam. Just we need to create the whether not state symbol is not available in the cadence, I think. So we'll be looking into how to create the symbols or bring the library in the cadence. Then we can.
There you can write a Verilog A code. Maybe you can check for it. Is there any Verilog code?
Okay, madam.
It's available that you can create a symbol. Options were available.
Okay,
so
madam.
You can do that. But you check for the nanometer, which nanometer? Yeah.
Oh, yes, madam. Definitely, madam.
Good. Nice presentation, sir.
Thank you, madam. Thank you, madam.
Sir, any difficulty in implementing this this memristor in that any integrated circuits or in processors? Any difficulties in there, or we can implement same as CMOS technology? Hello.
Oh, sir, 1 minute wait, sir. There is some technical problem. We'll join again.
Okay, okay.
Sir, my voice is audible?
Yes, yes, sir. Now it's audible.
Sorry, sir. Some network problem, sir.
Okay. Sir, any difficulty in implementing this memristor in that integrated circuits or processors compared to CMOS technology?
So sorry, sir. Can you repeat your question?
No. Any difficulty or is it same implementation as CMOS technology, or we will face any difficulty in implementing this memristor logic in processors or integrated circuits?
Oh, yes, yes. Actually, we are just simulated, sir. Still, we are not went deep into that, how it is fabricated and how it is implemented. We need to do some research on that, sir.
Okay, sir. Thank you. That is the question.
Thank you, sir.
Next paper ID 159, Design and Development of Health Monitoring System using Sensor. This is Bhavatarani, Ms. M. Kartiga, Ms. P. Priyadarshini, and Mr. V. Suresh.
Shall I can share the screen?
Yes.
Visible? The screen is visible?
Yes, your screen is visible, but your presentation is not. you're having any problem in presenting, we can do it.
Now whether visible?
No. So shall we present from our side?
Yeah, okay.
Are you using your mobile phone, ma'am, for presentation?
No, I am using my laptop.
So I think your our side screen is visible now.
Yes, is it visible?
Yes, okay, you can do.
Kartika, can you start the presentation?
Our project title is Design and Development of a Health Monitoring System using sensors. The following slide presented by Bhavadharni and the Priyadashni.
Kartika, your voice is breaking.
Next. Okay. Our project focus on the sensor. So the introduction of this introduction is a sensor is a device that measures physical input from its environment and converts it into data that can be interpreted by either a human or a machine. Here the most sensors are electronic, but some most simple such as a thermometer, which presents the visual data.
Kartika, your voice is breaking. Please check your network connectivity.
Now it's okay.
Please be louder.
What about now? Okay. Here project we use, there are three types of sensors. The one is heart rate sensor, the other one is temperature sensor. In temperature sensor we use only pH level. The heart rate sensor is nothing but it measures the pulse waves, which are changes in the volume of your blood vessels that occur when the heart pumps blood. Heart rate monitors work by measuring electrical signals from the transmitted to data center. There are three nodes in heart rate sensor. Why we RTD? Why we use temperature sensor? Means temperature sensor is an electronic device used to take accurate temperature measurement readings. In a specifically, we use LM35 temperature sensors only. It's having an analog output voltage proportional to the temperature. It has the three nodes in LM35. The first pin is refers to voltage, and the second pin is output voltage, and the third one is ground. Next. Next slide. DH11 temperature and humidity sensor. In this particular sensor, we use measure the temperature and the humidity. The DH11 is a ultra low cost digital temperature and humidity sensor. It uses a capacitive humidity sensor and a thermistor to measure the surroundings air and spits out a digital signal on the data pin. It has the 4 pins. The first one is the voltage, and the second one is data is input as well as output. The third one is not it is an optional pin, and the fourth one is the ground. The above the further slides are presented by my friends Priyadashni and Bhavadharni.
Primary objective of a project is we are designing and developing an automated system for continuous measuring of heart rate, humidity and body temperature using the sensors, and also to develop a mobile application which displays the patient's body parameters just by scanning the application barcode. It also to analyze the changes in value of various parameter in regular intervals to monitor the health of the patient. Next slide. So the proposed method is wireless electronics with sensors, and an application will simply simplify monitoring and regulating one's health and surroundings. The hardware components used is DHT11 sensor, temperature sensor, humidity sensor, LM35 temperature sensor, heart rate sensor, Arduino UNO, and HC05 Bluetooth module. The proposed system measures the body temperature, heart rate, room temperature, and humidity. And by scanning the barcode, it will be displayed in the application. And the software tools which we are using is Arduino IDE and MIT app inverter. So this is the block diagram of a project. All the sensors are interfaced to the Arduino UNO. Arduino UNO is like an interface which connects all the data from the sensors and displays it. It is like a microcontroller, but it is advanced of a microcontroller, which is very easy for programming. And the Bluetooth module is just for a wireless communication between the sensors. So within the 100-meter range, the data can be transmitted to the Arduino UNO. Next. The proposed system integrates a system with an Arduino UNO board to collect the data with Bluetooth technology and direct touch by the sensor. By placing a finger on the heart rate sensor, the mechanism is activated. It monitors the temperature and the heartbeat and shows the information in the smartphone. How the heart rate is measured is like by the ventricular contraction of the heart rate. The heartbeat is measured. At regular intervals, the system efficiently measures and rapidly shows the changes.
The proposed system, it consists of an Arduino UNO, it being an interface for all the sensors, LM35, DHT11 and heart rate sensor, and the HC05 Bluetooth module. The Arduino UNO is a microcontroller which is based on an Atmega 328, and the Arduino UNO, it consists of 28 pins, naming from 6 analog pins from A0 to A5 and 14 digital pins from D0 to D13. This being the interface for all the sensors, we have used 3 sensors. LM35 is a temperature sensor for measuring the temperature of the external environment. Actually, LM35 has 3 pins, namely VCC, data pin, and ground. In this proposed system, the LM35 has been connected to the D2 digital pin of the Arduino UNO, and the heart rate sensor, the data pin is connected to the analog pin A0 of the Arduino UNO. It is for measuring the heartbeat rate of a human, and this HC05 Bluetooth module is for connectivity purpose, as we measured this temperature and we are going to display using the mobile app by use of Bluetooth technology. So we are using HC05 Bluetooth module, and it has 6 pins, and here TX and RX is being the major for transmitting the serial data as well as receiving serial data from the Bluetooth module. The transistor TX is being connected to the D10 of Arduino UNO, and RX is being connected to D9. DHT11 is for measuring the humidity as well as the room temperature. So the data pin is being connected to D7 of Arduino UNO. This is the proposed system we have established for our system. Next slide. We have observed the result as body temperature is being 85.6 and room temperature is 26 and body humidity is being 76. It represents very humidity level, and heartbeat rate is from 75. It mentions in all heartbeat rate of human. This results we have obtained from the scanning the barcode of the mobile app we have been developed using the app. Next slide. These are the literature survey we have undergone for our establishment of the monitoring system. The first is the IoT-based patient health monitoring system. We have this is for IoT-based monitoring. Continuous monitoring is being done here. It is like a wearable we can wear in our human body. The limitation is that it reduce since we are using IoT, it have high cost. That is the only limitation we have. Health monitoring device is the next paper we have monitored. Here, the observation is being many critical patients need high attention in IC unit. So this device has been very useful in monitoring all the body related parameters. Next slide. The third and fourth paper is for monitoring the humidity as well as the body parameters, IoT based parameters as well as humidity monitoring based on IoT. These two papers based on IoT only. We have received a better efficiency, and this paper helps us to develop our system. Next slide. So these are the references we have undergone for our paper. Thank you.
Thank you for your presentation. Can you please, anyone answer that how much input voltage you have to use for the sensors? You listed 3 different sensors: temperature sensor, DTH sensor, and heart rate sensors. So what should be the input voltage for those sensors to work?
LM35 needs 4 to 20 volt. Basically, for all sensor, we have given 5 volt range voltage as an input.
4 to 20 volt.
BCC.
Okay, what is the need to measure the room temperature there by using DTH temperature since you are monitoring the health?
Sometimes the room's temperature can affect the body, like the cold surroundings can inhibit fever like that. So to measure that, we have used DH11.
So the normal temperature sensor senses the temperature of the body, and the TTH will measure the temperature of room surroundings.
Yes. Yeah.
Okay, almost nowadays people were using the watches and more items. Even in mobile phones also we have such options. Some apps were available when we can calculate the steps, heart rate we can be measured, and other options were available comparatively. How you can able to justify that your system can be better than those available products?
Actually, we are going this as an extended project, like we have done with hardware by buying the sensors and connecting those. So we are going to validate the sensor using console software. This is our extended main project. So that is the reason why we have chosen this project. We are going to just validate the results obtained from the hardware as well as software are same.
No, is it fine? I'm not asking about the objectives. I'm asking like already products were available for this health monitoring. Almost people were started using the smartwatches and even mobile phones also. Some apps were available to monitor our health, how much step count, calories, how much it's burning, even heart rate, everything can be measured through that. How you can justify your system can have a better, or what advantage your system is having compared to the available product? My question is clear for you.
This can be available. Yeah, right. Yes, I am aware of it. The Bluetooth is the technology we're using in our project. So the Bluetooth is available even in basic mobile phones. So it will be easy other than Wi-Fi or other modules.
Okay.
In one of the slides, you have put like body humidity. What is that?
Room humidity.
No, I saw like body humidity somewhere. I have noted that. I'm not sure why you have put like that.
Actually, we only monitor the room humidity. Maybe due to some mistake, we have written as humidity. Sorry for that.
Okay, any app you have developed for this, or you are using the existing app for this application?
No, we have developed the app by initializing the block well as code. We have did using MidApp Invet to develop the app.
What about the barcode? Are you able to implement that here? Because you said that you are using the barcode, right?
Yeah, actually in MidApp Inventor, we have two stages. First, we need to connect the block as chains, and in second, we need to initialize the block. After two steps, we will generate an barcode in the tab. By scanning the tab in our phone, we can use the tab in the phone.
Okay. Okay, that's okay.
Thank you.
Hello. Ma'am, I have one question. Actually, these type of sensors are already used for last 3-4 days, years before itself, for measuring the heart rate and temperatures of the body, everything. What is your novelty of this work compared to the previous year, previous literature?
Compared to this is not an advanced technology. It is simply a Bluetooth technology only. But we are in the idea of developing by software, by fabricating the sensor. So as a basic, we have used this. This is not an advanced, and this is already in use only.
Okay, ma'am. Because in 2017 itself, there is some Bluetooth low energy technology concepts are available for the same ICU, even in ICU healthcare, in healthcare in ICU rooms and all. Okay, thank you.
Thank you. Next paper ID is 172, Analysis of Power in Logic Circuits Using Various Clock Gating Techniques. Authors Dr. R. Rajalakshmi, Dr. P. Sivakumar, Mr. Devarajan, Dr. S. Vasundhara, and Mrs. G. Subhashni. Can you please share your screen now?
Yes, ma'am. Is it visible, ma'am?
Yes, ma'am. Yes, ma'am.
Ma'am. Good afternoon, everyone. I am Vasundhara, final year student from ECE Session Engineering College. Today I am here to present a paper on analysis of power in logic circuits using various clock gating techniques. Problem statement. Due to widespread application of electronic devices like mobile phones, laptops, etc., power dissipation has become a critical parameter in VLSI design circuits. The circuit complexity and high-speed performance increases the power consumption. Therefore, the reduction in power, area, and the improvement of speed require optimization at all levels of design procedures. To overcome all these problems, we are switching over to clock gating techniques. It is a technique used in very synchronous circuits for reducing dynamic power dissipation by removing the clock signal when the circuit is not in use. While optimizing the power, clock gating logic is an important consideration
in the performance of digital system. It also reduces unwanted switching on the clock nets. Lower power consumption while designing semiconductors is necessary to achieve longer battery life. The reasons why we go for clock gating are it is used to reduce the dynamic power consumption and reduce clock network power consumption. Both the battery operated devices and high performance computing system use this clock gating technique. If not, they use other low power techniques like power gating, supply voltage reduction, multi-VT cells, multi-voltage designs, etc. Global clock contributes to 40% of the total system power dissipation. The enabled signal must operate at much lower frequency than the clock itself. Otherwise, it may overweigh the power saving. These are the literature survey we gone through. A novel glitch-free integrated clock gating cell for high reliability. Methodology is developed a novel glitch-free integrated clock gating cell. The advantages is glitch-free operation is achieved. The limitation over here is larger delay and power. Then the power reduction and domino logic using clock gating in 16 nanometer CMOS technology. A new power reduction technique with clock gating logic is done. Proposed domino logic is a very low power design in ultra deep submicron technology, and the design dissipates less power with some loss in performance. Register grouping from synthesis of clock gating logic. Then the methodology is a new grouping method based on iterative maximum weight matching. Advantages is average rate of power consumption. Then the next one is dynamic power reduction of synchronous digital design by using of efficient clock gating technique. The method is developed a new double gated 3-state clock gating technique. Advantages dynamic power reduction and reduced clock power complexity. The limitation is hardware is very complex. An efficient clustering algorithm for lower power clock tree synthesis. The method is a polynomial time greedy clustering algorithm. Advantages is reduced clock tree power consumption, interconnectivity, and total capacitance in the clock tree. Disadvantages impact on the noise susceptibility and the availability of routing resources for the signal nets. Then the next one is the optimal fan-out clock network for power minimization by adaptive gating. Probabilistic model of the clock gating network. It saves 10% of the total switching power of the clock tree. Then the disadvantage is average rate of switching power. Next one is power optimal buffer clock tree design. A new clock network design and greedy heuristic algorithm is developed. Significantly better than previous approaches in terms of wire length, buffer area with a higher power dissipation and rise times. The next paper is clock distribution networks for 3D integrated circuit. Method is 3D CDN topologies. It reduces the clock skew and the power consumption with average rate. And the last one is combinational algorithms for fast clock mesh optimization. Combinational algorithms for fast clock mesh optimization is developed. It optimizes clock mesh and consumes larger wire area. Then power dissipation in CMOS circuit. First one is peak power. Then the second is time averaged power. Time averaged power is further divided into static power dissipation and dynamic power dissipation. Static power dissipation is more essential during standby, mainly in battery powered devices. Inactive logic gates are connected to static power dissipation. Dynamic power dissipation is mostly generated by current flow through charging and discharging of capacitance. It is further classified into switching, short circuit, and glitching. Now let us see about peak and average power. In the graph, we can see the peak power in the maximum position. It refers to maximum power drawn by the circuit. Hence, reducing the peak power is essential for reliable functioning of the chip. The system overheats due to higher power consumption and thereby reducing the circuit's reliability and lifespan. Next one is average power. It refers to the average of the instantaneous power dissipated over a time period T. If the average power is high, then the battery life will be reduced. The next one is clock gating techniques. It is used to prevent unnecessary power consumption, such as power wasted by ideal timing components. It is the process of disabling the clock signal, particularly useful for flip-flop when an information does not change the stored information. Clock gating occurs largely at register transfer level. Types of RTL, combinational clock gating, sequential clock gating, system level clock gating. Combinational. It is a simple substitute for RTL code. When output does not change, it saves power by shutting off the clock on the registers. It also maintains 1-to-1 state mapping with the original RTL. Functional verification can be performed using combinational equivalence checking tools. Second one is sequential clock gating. It alters the microarchitecture of the RTL without impacting the design's functionality. But sequential clock gating possibilities are difficult to identify. It saves a large amount of power, often lowering switching activity. Then the next one is system level clock gating. Clock gating at the system level disables every RTL blocks because huge parts of logic do not shift for a long period of time. It provides the greatest potential for power saving. For example, based on the device present working mode, sleep modes on a mobile phone may selectively disable the any part like display, keyboard or radio. Efficiency of clock gating techniques. A clock net is responsible for a large part of power dissipation in synchronous digital circuit, up to 40%. Clock gating limits the unnecessary switching on the clock net paths by disabling the clock. It is a technique that can be used to control clock net power dissipation. It can save more power by not clocking the register if its state is not changed. It consumes power continuously because it toggles the registers and their associated logic. The clock gating shuts off the clock while the system maintains its current state in order to reduce power consumption. Then the technique we are using is latch-free design. It is a simplest clock gating method of the design. From the name itself, we can observe that there is no latch present in the circuit. It consists of AND gate and XOR gate. If the clock is active on rising edge, we can use AND gate. If the clock is active on falling edge, we use XOR gate. The issue here is that if the enable signal is not active between clock pulses, the gated clock's source may end early or have mismatched bits. Latch-free design uses AND gate to get the clock signal. XOR gate, which is between the D input and Q output of the flip-flop, has been used as the enable signal for a clock gate. The next technique is latch-based design. It comprises of latch, XOR gate, and AND gate. It also assists to eliminate glitches. The enable signal is propagated to the input of AND gate at the falling edge of the clock signal. The level sensitive latch can hold enable signal when clock is high. It saves power and space, but it requires more timing testing. Pipeline circuit. Consideration in implemented clock gatings are: first one is when the clock is high, the enable signal should remain stable and can only change when the clock is in low phase. In order to guarantee correct functioning of the logic implementation, after the gated clock, it should be turned on in time and glitches on the gated clock should be avoided. The next one is additional clock skew may result from the AND gate. The clock skew could be important and needs to be taken into careful consideration for higher performance design with a short clock cycle time. This is the pipeline circuit with the C17 benchmark circuit. These are all the simulation results we obtained. This is for latch-free clock gating. Then the second one is for latch-based clock gating. This is the simulation result for a pipeline circuit. Then the last one is without using any clock source. Now let us see the comparison of power and lookup tables of various gating techniques. Latch-free clock gating has dynamic power 0.271 watt and static power is 0.245 watt and total on-chip power we obtained is 0.515 watt. And we used one lookup tables. Likewise, latch-based clock gating has a 0.288 dynamic power and static power is 0.245 watt and total on-chip power is 0.533 watt and number of lookup tables we has is 2. Pipeline circuit has dynamic power is 1.286 watt and static power is 0.254 watt. Total on-chip power is 1.54 watt and it has high lookup tables 7. Then the last is without clock gating. It has dynamic power is 0.265 watt, static power is 0.245 watt. Total on-chip power is 0.51 watt and there is no lookup tables in the last one. Conclusion. Clock gating methods have been investigated. The clock gating techniques is used for simple sequential circuits or latch-free, latch-based and pipeline circuits. This is done to analyze the power and the area of the above mentioned circuit. To define the efficiency of the clock gating technique in logic circuits, simple and pipeline sequential circuits have been developed. The prior date for this technique is also to reduce power and therefore the power summary is evaluated. This technique reduces power by turn of the inactive states. Designers prefer clock gating technique to reduce overall dynamic power. These are all the references we have gone through. That's all. Thank you.
Thank you for your presentation. You were mentioned like you are using the clock gating to reduce the power consumption, and the result sheet or comparative tabulation, whatever you showed, like your dynamic power has some variation, but the static power is constant for all the different techniques, whatever you displayed. Is there any particular reason why only the variation in the dynamic power and constant static power in the presentation?
Static means it always remains same. We can observe that the pipeline circuit only consumes more power, more dynamic power.
Is there any other option to reduce the static or leakage power?
No, ma'am.
Do you have an idea about power gating, like how you are explained clock gating? Is there power gating is also available? Do you have an idea about those things?
No, ma'am.
Okay. Like actually those power gating will have an impact with the static or leakage power. Whatever you displayed here is only with the dynamic power reductions by using the clock gating, but the power gating also available to have an impact with the static or leakage in power. So you just go through that. At least in the theoretical point of view, you should have an idea about those things.
Okay.
And in your presentation, you mentioned like more about the power analysis, and you have a reduction in the power consumption or other thing. And what about the area and routing? What is the relation you have if you have a reduction in the power? What about area and routing? What impact it's having with the clock gating?
Ma'am, it consumes more memory, ma'am, while simulating.
Memory and about area?
I just mentioned that as a area. Sorry, some mistake will be there.
Okay, what is the meaning of area then? How you can relate your power and area? What is the relation it's having? Do you have an idea?
No, ma'am. Sorry.
Okay, pa, all the best.
Thank you.
Sriram?
Yes, sir.
Yeah, nothing from my side. You can go ahead.
Okay.
Thank you for your presentation. And the last paper, ID is 321, IoT-based requested usage of welfare equipment for alcohol and accident detection. Mrs. R. Ramalakshmi, Ms. L. Nirmala, Ms. T. Vidula. Nirmala, can you please share your screen? Vidula? Vidula, Nirmala, am I audible?
Ma'am, now it's visible, ma'am.
No, your screen is not visible. If you're having any issues, we'll share your screen. Yes, now it's visible. Yes, visible. Please show in full view. Yes, okay. You can proceed now.
Good morning to one and all present here. I'm Nirmala from Ramco Institute of Technology. My paper is IoT-based request usage of welfare equipment for alcohol and accident detection. Nowadays, we are facing a lot of accidents in the present era, and many people are losing their life due to the drunk and drive accidents. So our main objective is to develop a system to safeguard the individual after the accident, and the proposed system gives the indication of alcohol level if the person is drunk. The objective is our system is implemented as such a way that vehicle will not ignite until the safety is that paused. In this paper, the safety test means alcohol test, which will help to solve the problem of drunk and drive. And if the vehicle has gone through an accident, its geographical location on the map is located, then the alert message will be given to the nearby hospital and family members. The literature reviews are. From this paper, we refer a system to use the blood alcohol concentration, smart detection of vehicle accident using the object identification sensor with the artificial intelligence systems. In these papers, we refer the identification sensor with the artificial intelligence systems. On IoT-based vehicle accident detection reporting on navigation. In this paper, we refer the GPS, how it's work, and the vehicle accident detection. The next paper is an automatic car accident detection method based on the cooperative vehicle infrastructure systems. In this paper, we refer a deep neural network method and how it's worked in the automatic car accident detection methods on CVIS. CVIS means a cardiovascular information system. It has become a default descriptor for what is unfortunately or rapidly changing in the technology. In our system, safety is main. So first we check the seat belt is locked or not. If the seat belt condition is false, if the engine will be off. If the seat belt condition is yes, the vehicle is on condition, but the engine will be off condition. Then we go for alcohol detection. In India, the permissible blood alcohol content is set 30 milligram of alcohol per 100 ml of blood. It will be checked driver alcohol level is maximum or low. If the alcohol is maximum, the information should be family. The information shared should be a family members and also engine is off. If the driver alcohol is maximum, the engine will be on. The driver alcohol is minimum, the engine will be on and the car is moving on condition. Then we go accident detection condition. If the condition is true, the victim default will be sent to the server, and GSM and GPS related will be sent to the information to the sensor. It also send the GSM to the respective rescue or police stations to track the victim and also rescue them. If the accident detection is false, the car will be in the moving condition. 3 mechanisms are involved in the project. Prevention is seat belt check, and detection is alcohol level is in the driver. Alerting is information shared. The overview of accident detections or monitoring system is very helpful to detect and monitor the accident. A panic button is fixed into the system. The vibration sensor is used to detect whether the accident is occurred or not. If the panic button is switched on, then the victim details will be sent to the server. GSM and GPS models will send the information to the server. It also sends a SMS to the respective rescue team or police station to track victim, also the rescue team. First, we have start the accident detection or panic buttons to switch on. If the panic button is on when the accident is occur, it will be detect and send the victim detail to the server. Also track the victim and send message. Next will be continued by Vidula.
Accelerometer. An accelerometer is a device that measures the vibration or accelerometer of motion of the structure. Accelerometer-based alcohol drinking alert device will be able to communicate with the user mobile phone. In the mobile phone, we can check the person's status, which is based on accelerometer reading. We can tell whether the person is standing, walking, or drunken based on this reading. Nowadays, lots of accidents happen on highways as a result of an increase in traffic and put together as a result of rash driving of the driver. Thus, drunken driving is also a significant reason for accident in most countries within the world. To build a proper and foolproof system that can be planned by accident, it provides more accuracy in detection of alcoholic person and save people life that sit in the car in situation of an accident. In the safety system enhancement, the number of accident is decreased, which is alcohol consumed drivers, and save humans life because of accidental system has to be installed inside the car. The proposed car safety system is based on different types of sensor to collect the car parameter conditions. Process is to take the corrective decision at any time and anywhere, and transmitted with the current location using wireless communication element, GSM and GPS modem. However, this process system has fulfilled challenges in terms of cost, energy, communication technology. And next one is ultrasonic sensor. An ultrasonic sensor is an instrument that measures the distance to an object using the ultrasonic sound waves. An ultrasonic sensor is an electronic device that measures the distance of target object by emitting ultrasonic sound waves and convert the reflected sound into an electrical signal. Ultrasonic waves travel faster than the speed of audible sound. And then ultrasonic sensor works by emitting sound waves at a frequency too high or human to hear. They wait for the sound to be reflected back, calculating distance based on the time required. And next one is Blink. Blink is a platform with Android apps and iOS to control the Node MCU, Arduino, Raspberry Pi 3, and the likes over the internet. It has a digital dashboard which is very easy to use, where we can build a graphic interface for your kid by simply drafting and dropping the widgets. Blink is an IoT platform designed to make development and implementation of smart IoT device quick and easy. It can be used to store, read, and visualize sensor data and control hardware remotely. And next one is Blink is a recently that allowed you to quickly build interface for controlling as well as monitoring hardware project from your iOS and Android device. While the Node MCU is excellent open source hardware for getting started with the Internet of Things, Blink is an ideal platform to control the Arduino, Raspberry Pi, and other versions. The concept of the virtual pin is invented by Blink to provide the exchange of any data and information between Blink mobile app and hardware. Virtual pins are entirely distinct than digital and analog input and output pins. They are physically pins or the microcontroller board where we connect sensor and actuator. Blink is free to download from Play Store. All we need to do is create an account in the app. The open source Arduino integrated development environment makes it easy to write code and upload it to board. It runs on Windows, Unix, and Linux. This environment is written in Java and based on processing and other open source software. This software can be used with any kind of Arduino boards. Next one is features: Wi-Fi, Bluetooth, Ethernet, USB, and GSM. And next one is connection type: Ethernet, Wi-Fi, Bluetooth, cellular, and serial. And Blink ecosystem: Intent IoT solutions, Spark Fun Electronics, Arduino, Texas, and last one is Particle. And next one is experimental setup. Is a AVR Studio, and AVR Studio in version 5 at any time of writing is a development environment produced by Atmel especially for the AVR family of microcontroller. As it is more dedicated than other IDEs, it has debuting and stimulation tools that surpass that available elsewhere. Its primary drawback is that specialized and cannot be used to develop programs for microcontroller outside this family. Ellipse is used programming the 80 Mega 644p as well as for creating project within Ellipse is provided in Appendix C. Otherwise, there is a most certainly or other choice available. These two are the best. They provide a great number of features useful in development and are both well supported in the community with the help of easily available. And next one is hardware. A T Mega 644p is an 8-bit microcontroller from the AVR family produced by Atmel. There are the varieties to choice for, however, the STK500 is good choice. It's a development based capable of handling a number of different microcontroller, provides the hardware for connecting the microcontroller to a computer using the serial via the RS232 standard and provide 8 switches and LEDs for use with fundamental programs. Most pins have multiple names as they are used for different tasks by distinct peripherals. And this is the alcoholic induction result. And this is the accident detection result. Conclusion. The paper presented the existing issues of accident detection. The proposed paper mainly focused on alcohol detection and accident detection. The proposed system would be helpful for detecting alcohol and accident through receiving message and location to aid before leading to any disaster to the lives of people. Future scope. The system is to control the accident and providing useful details about the accidental vehicle, thereby reducing the rate of accident taking place due to drunken driving. The proposed system deals with the detection of the accident, but this can be extended by providing meditation to the victims at the accident spot. By increasing the technology, we can also avoid accident by providing alert system that can stop the vehicle to overcome the accidents. And these are the references. Thank you.
Thank you for your presentation. See, your system is basically, it will be in the vehicle, inside the vehicle. So it's going to be test the driver who is going to drive. Is it correct? My understanding is correct?
Yes, ma'am.
So maybe it's for both two-wheeler and car, or what is your plan? Like how, where it's going to be placed this system, whatever you are developing? It's in front of driver or while entering into the car, or where you are planning to keep this system in the vehicle?
Ma'am, the alcohol detection is placed in the category in front of the driver, ma'am, so during the driving.
Where? I'm not able to get your voice. It's breaking. Where it's going to be placed? Can you please repeat?
Ma'am, it's placed with steering, ma'am. Alcohol detection is placed with steering, ma'am. And GPS and GSMs are under the car is placed, ma'am.
It won't be like a system, handy system. It will be like a different places in the car it will be placed.
Yes, ma'am. It will be different place take place, ma'am. Connected with the one node, ma'am. That MCU.
Okay. The sensor, whatever you are using is, what is the range it can cover? Since the driver seat cannot be in the same position as others, so it will vary for individual drivers also. So how much distance your sensor can detect the alcohol, whether they had or not? The distance of the alcohol sensor. Since usually maybe in the movie and all we were seeing like the policeman will have that, and the equipment whatever they are having is, it's need to be very near and they have to blow into that. So the distance should be very much closer to the person as well as the sensor. So your system, if you are keeping in the steering, how efficiently it can detect and what is the distance it can cover, your sensor can cover. Am I audible? Hello, am I audible?
Yes, ma'am.
Yes, ma'am. Audible, ma'am.
Yeah. Thank you.
Yes, ma'am.
Nirmala?
I think Sriram sir can proceed.
Yeah, which one did you use, like Raspberry Pi or Node MCU or Arduino for this implementation?
Arduino and Raspberry Pi.
Arduino. You didn't use the Node MCU then?
Yes, sir.
Oh, you use the Node MCU. Correct?
Yes.
Okay, if you use the Node MCU, then what is the use of Arduino and Raspberry Pi here? Because I know that we can do some basic performance of Arduino in Node MCU itself, if I'm not wrong.
Vidila, are you there?
Yes, ma'am. Yes, ma'am.
May you kindly answer for the question?
I'm just asking which device you use for this implementation, Arduino or Raspberry Pi or Node MCU?
Arduino and Raspberry Pi, sir.
Okay, then what is the use of Node MCU here? Why did you use the Node
It's
MCU?
an open source Internet of Things. It's a platform which compresses a firmware that runs on the ESP8266 Wi-Fi module.
I think there is a Node MCU module. There is a separate Node MCU module is there instead of Arduino. Why didn't you choose that separate Node MCU module instead of Arduino and ESP? Because you have to use Arduino and also another one small ESP module. I think they have already integrated those two in a single Node MCU chip, I guess, if I'm not wrong. Okay. Then Raspberry Pi, why did you use the Raspberry Pi? Okay, no answers.
I hope so, no answers, Sriram.
Okay, because those are the major components that they are using in the system. Then not sure why they have used those Arduino or Node MCU there. Also, GSM and GPS. Did you get the output of GSM and GPS and GSM? Sorry. You can able to bring out that working model with GSM and GPS. Okay, we can close it. I'm not sure you can answer.
Okay, thank you. Ma'am, Vimala ma'am.
Yes.
Can you please give any suggestions for the presenters?
Yeah, sure. Almost, I think paper ID 77 and 277
Yes,
is
ma'am.
not there.
Yes, ma'am. Yes, ma'am.
Thank you for all the audience for your nice presentation. And maybe VLSI is a very important domain because it is very useful for the compact design. And it has very small power consumption as well as more advantages compared to all discrete circuits. So almost in the papers, whatever we are having is most into the VLSI, and some applications kind of presentations were also there. And I'm very happy to be here that more into the circuit level implementation like memristors kind of thing, and they were implementation in the current mirror circuits, and somebody were presented about this thin films fabrication structures also. So those kind of presentations are very much important for the future VLSI design, and it can be very appreciated from the audience point of view also. So thank you for the opportunities given for me to be part of this conference. Thank you, Raghavan sir and ma'am. Thank you.
Thank you, ma'am. Sriram sir.
Yeah, thanks, ma'am. As alumni of RIT, I am really grateful to be here. Also, I'm not sure, like, this is my first conference that I am attending as the chairperson, and really fascinating things like the first one, that Cobalt, that is really a refreshing content for me. Also, that memristor also, that is quite good. Thank you. Thank you.
Thank you. Next vote of thanks given by Miss Dichana and Miss Apinasri.
Good afternoon to one and all present here. It's my privilege to propose the vote of thanks to this August gathering on the International Conference on Smart Technologies and Applications, ICSTA 2022. First and foremost, I wish to express my sincere gratitude to Dr. P. Vimala and Mr. Sriram Alagraj for their presence. We thank both of you for your valuable feedback. Through your thought-provoking comments, all the participants and presenters gained more knowledge in VLSI design domain. Last but not the least, my big thanks goes to all presenters and participants for their active participation. Once again, thank you all.
Thank you. So participants are kindly requested to fill the feedback form given in the chat box itself.
Kindly noting, all the presenters should fill the feedback form, then only the certificates will be generated.